Good evening and welcome to the session. My name is Dmitry Belyaev and I'm an independent consultant helping companies to build modern cloud-native software. And today I'm going to talk about database migration in Spring Boot-based applications. Spring Boot has a very good support for database migration. It works smoothly. It supports both of most popular choices, Flyway and Liquibase. And if we use database migration with Spring Boot-based applications, that the database migration is executed on the service startup. And for today's session, I've prepared a small demo application which will help us to see how fit the Spring Boot, how well the Spring Boot feature fit production operation. Right? And this demo application is an imaginary customer profile service, microservice, which is responsible to manage customer profile data. And let's say we are following the lean product principle. So we try to release the first version with a minimum functionality which can be useful for our customers. And we've chosen a pretty simple data model for that. So we have a customer profile table with the basic attributes like name, email address, and this table references the address table, which contains the postal address of a customer, right? And it also implies that the relationship between these two objects is one-to-one. So in the system currently we can have just one postal address per customer. As a deployment platform, I've chosen Kubernetes as a most popular or one of the most popular choices nowadays. I have a kind cluster running on my laptop, and as a database I've chosen Postgres, again one of the most popular choices in nowadays, and I have Postgres running in a container on my laptop. And let's start with the deployment of this initial version of the application. So I'm going to check out the version 1.0. And in this version, we have the migration script, which is going to create this initial database structure. Right? We have a customer profile table, address table, and a foreign key constraint on the customer profile table. Right? I have few scripts to perform all the basic operations. To save some time for this session, I'm not going to build and push images of every version. All the images are already pushed to the Docker Hub image repository. So I'm going to start with the deployment. I'm using K9's utility to observe what's going on the cluster. As you can see, I have no pods running in the default profile. So then let me go back to IntelliJ, to the terminal here, and I'm going to start with deployment. And while deployment is running, we can have a look at the deployment descriptor, which is pretty simple. So I have one deployment, which will start 2 pods. Each pod contains just one container of version 1.0 of my application. And as a good citizen, I also configured readiness and liveness probe. And liveness probe is of interest for this session. So the liveness probe will fail after 1 minute, as it is currently configured. Right. What is also here is the database connection parameters are passed to the service through environment variables, so to follow the best practices of the cloud-native services. And there is also a service enabling access to this deployment. And if we go back to the class, then we see that both pods are now running. And I can call the endpoints on these pods. To do that, I have to enable port forwarding because I don't have ingress configured in my cluster. Right? So I need port forwarding, and then I'm going to use built-in HTTP client in IntelliJ to call the endpoints of this application. Right, so I can start with a health endpoint, and we can see that application is up and running. I can create a customer profile. There is a successful response, and if I take this ID and use it here in the get operation, then I think we can also read this customer profile. So everything is fine, application is running, version 1.0 is successfully deployed. And let's imagine that our business is pretty successful. We have fast-growing customer base, and let's say we reach the point where we have 2.5 million customers. And to emulate the situation, I have this small utility class which I can run to create 2.5 million records in the database. Right, let me start it. Yeah, so the data generation is running. And as I said, we have a pretty successful business, so customers are happy using our online shop. And this customer profile microservice is part of this online shop. But the customers started to complain that one address is not enough, because sometimes people want to send whatever they purchase to their, let's say, children or their parents. And with the customer profile service, which we currently have, they have to type these additional addresses every time again and again. And of course, we want to have our customers happy and satisfied. So we decided to release version 1.1, where we change the data model to support multiple addresses per customer, which means we have now the address table references customer profile table, and we also added a new column saying whether this particular address is a default address for the given customer, not this Boolean column main, right? So we are done with the development. Let me go to the version 1.1, right? And we have this migration script, database migration script. What we have here, we create additional columns in the address table, right? Again, we have to define the foreign key constraint for the reference from address table to the customer profile table. We also create an index here, and we do the data migration, right? Because we don't want these 2.5 million people to type their postal addresses again, right? So the data migration is also pretty simple. So we have to update address table, setting these two new columns which we introduced in this version, right? So the main flag will be set to true per default, because currently we support only default addresses, main addresses of customers, and the profile ID has to be set to the profile ID following the reference as it used to be, right, in the version 1.0. So we, let me make it a little bit bigger. So we have to select ID from customer profile following the reference as it is defined in version 1.0. And if I start the deployment of this version, so the same procedure, I'm just starting my deployment script. Right, so the service is unchanged, but the deployment is changed. And if we have a look at the cluster, we see that Kubernetes is doing rolling deployment. So the Kubernetes tries to start a new pod with a new version of our application. And let me start the port forwarding again and try to do the same GET request. And there is no response, right? And no response. So our service is not responding anymore. And if we have a look what's going on with this deployment, we see that the schema change was successfully executed, and now the data migration is running. Right? And it takes some time. And it takes more than 1 minute. And the liveness prop said that this container is not healthy, is not alive. It shall be restarted. And Kubernetes restarts this container. Right? So we see the number of restarts is 1. So we wanted to bring a new nice feature to our customers. But what we have achieved is that our service is close to unavailable because, let me go back to IntelliJ, and there is a response, but it took 51 seconds for this response to come, which is not acceptable, in my opinion, for an online service. Right? So with this deployment, we actually made our service not available, effectively not available, and we still don't have our new feature live. Right? And let's look at these two problems one by one. The first, this very long response times. There are two types of databases in relation to how they treat schema updates. The one type of databases includes schema updates into user transaction. And Postgres belongs to this group of databases. The Microsoft SQL Server would be another example. To be able to execute schema update, an exclusive table lock should be acquired. An exclusive table lock means that no other transactions can neither read nor write into this table. And that's what actually happened with our deployment. We have one migration script, which includes schema update and long-running data migration. And it's all executed in one transaction. So both database migration libraries, Liquibase and Flyway, they execute every schema update, every migration script in one transaction. So at the beginning of this transaction, when we do the creation of new columns, an exclusive lock on the address table will be acquired by this transaction. And then we do the long-running data migration, but this lock is still held by the transaction. And all other transactions should wait for this lock to be released. That's why our service is so unresponsive. To overcome the situation, what we can do, we can separate schema changes from the data migration, from long-running data migration. Because schema changes is actually just an update in the system table, and it's very fast. Right? And then this will not hold this exclusive table lock for so long. Right? And as I mentioned before, there are two types of databases. The one type, as Postgres, includes schema update into user transaction, and another type of databases, they don't include schema updates into user transactions. And MySQL or an Oracle would be an example of this group of databases. When we would use this other type of databases in this example, we would run into another problem. The schema update, the addition of new columns would be successfully executed in the first run. And then after restart, when a Spring Boot application would try to run the same database migration again, this migration would fail because the column already exists in the database. To overcome this problem, what we can do, we can write this database migration in the way that the scripts are idempotent. So you can run them again and again, having the same result. Right. Or another option would be to split the migration even further, having one schema update statement in one migration script. And I've prepared, again a new version of the application where I applied these principles. Right? So I can go to version 1.1.1, which is the bug fix version of 1.1. And check out it, and we can have a look how the database migration scripts look like now. And instead of just one script, I have two now. And the one script includes the schema updates, and I am also using this syntax which is supported by Postgres if not exists. So the column will be created only if it does not exist. The same about index here. Unfortunately, currently Postgres doesn't support this kind of syntax for creation of constraints. There is a solution for that. For the sake of simplicity, I haven't added it here. If you Google for that, you can find it. So you can query system tables, and then you can see that the constraint is there or not. With the Liquibase, you can use preconditions for a change set where you can query these system tables, and then either this migration will be executed or not. Right. And this is the first migration script, and the second one is the second one contains only this long-running data migration, right? And if I deploy this version of the application, so let's see. It is this is the old port of the version 1.1, which is in the terminating state now. This one is about to be started, and if I do the same GET request again, the port forwarding, sorry, port forwarding, GET request. Yeah, this is the showcase problem. It's blocked because I think this. Okay, it's terminated. Before we looked, and it was the old port was still in terminating state, and this port was holding this exclusive lock. So I think if I go back now, yeah, this is a problem of this previous version, and I think this container was killed. Yeah, and it's now the response is there. It took 35 seconds. Yeah, but this problem of not getting response instantly was because of the previously running data migration, which holds the lock, and then I think the container was killed by Kubernetes, but the log was still recorded in the Postgres. So splitting this migration script into two pieces, one having the schema update and another one containing the long-running data migration, can help us to overcome this problem with not responsive services. But we still have the second problem that our deployment, our new feature is still not available. Right? So it's already 2 restarts, and the Kubernetes will keep on restarting this container because this data migration takes a long time, and it takes longer than the liveness probe. How can we solve this? I think the easiest solution would be to increase the timeout. But the question is for how long? And this is a pretty simple demo application. and the volume of data is not really high. Right? In the real life scenarios, this data migration can take like 20, 30 minutes. And then if you set the liveness probe to fail after 30 minutes, then I think the angry customers would inform us earlier than this liveness probe, right? So it's not really a solution for the problem. And the solution is to treat database migration as a long-running process. And as such, it should be separated from the service startup. Right? So normally you want your services to start as fast as possible. And if database migration is something which may potentially run for a long time, you don't want to include it into the startup procedure because it's like contradicts your goal, your target to have your service startup time minimum, as short as possible. There are different ways how you can do it. Again, in this demo application, I have another version, which is version 1.1.2, where I am separating database migration from service startup. I'm using Maven multi-module project here. So I have two modules, two Maven modules, the application and the database. The application contains just the service without any database migration. So if you look into the resources, there are no database migration here. And the database module contains the database migration. All the scripts are here. And the both modules, they are assembled as executable jars. Right? The Spring Boot application, this is the way we all know how it will be assembled as a self-contained executable jar. And to assemble this module as a self-contained executable jar, I'm using Maven Shade plugin, which is actually the same plugin which is used by, I think, Spring Boot. And I have few very small classes here, which are which rely on the Flyway classes to start the migration. You can write the same for the Liquibase. It's also possible. Liquibase is a Java-based library, so you can call some classes from Liquibase to trigger the migration. It's pretty simple. It's just like this, I don't know, 7 lines of code. With the Flyway, something similar can be done with Liquibase. I have a class with the main method, which will be started. And as I said, this module will be also assembled as a executable self-contained jar. And based on it, I can build a Docker image, which can be deployed on Kubernetes. And in this case, we can even use a proper Kubernetes construct for long-running processes. We can use Kubernetes job, which is a dedicated object type in Kubernetes to execute long-running processes. Right. This is the deployment descriptor of the job application, the job which contains the database migration. Right? And again, I can start the deployment, and I can deploy job, which will execute the database migration. If we have a look at the cluster, so we see that the job is running, the database migration has been executing, and this is our old deployment, which is already which has already 6 restarts now. Right. In the real world, I would wait for the job to complete, and after that, I would start the service deployment. To save time here, I'm going to start service deployment without waiting. Job to complete. So again, I can say deploy app. Let's have, and we see now that this is the new pod which contains the newest version of the application, which does not include database migration. And it will take, you know, like 20 seconds probably to start. Let me see here. Yeah, the initialization is already completed. So it's gonna be available pretty soon. Yeah, and I think it's already available. And now Kubernetes is restarting the second pod. It will take another 40 seconds. Right. Like this one is the very old, our version 1.0. It is running already for 22 minutes. This one is already the new version, which supports multiple addresses per customer profile. And now we have both pods successfully started. So we don't have the issue anymore with the failed liveness probe. Right? And if I go to the IntelliJ, then I can again run, let's say, get command, post-port forwarding, sorry. Port forwarding, I can run get command, and I see that addresses are returned as an array. It is an empty array because the data migration is still running. The job performing the data migration is still running. I can create maybe a new one and then use this ID to read it. And yeah, this is an array containing just one address, but this is a new version which was successfully deployed. And just a quick summary at the end. In my opinion, the database migration should be treated as a long-running process, and as such, it should be separated from the service startup. This might be not something what you want to do at the very beginning when you just start a new product, a new application. Normally you want to move fast, and then this built-in Spring Boot feature can be a good help for you. But when your application gets more and more mature, the volume of data growing, then you can potentially run into problems. One of the problems we saw today in this session. So then it would be advisable to start thinking about splitting the database migration from the service startup. Also, it's a good practice to separate schema changes from the long-running data migration. It's always good to have your schema changes idempotent, not only if you use MySQL or Oracle, but in any cases, because I can easily imagine a situation that a developer tried to test, let's say, an index in the test database, so created this index, did some tests, and then did not delete it. And then the same index is a part of the database migration script. You run it, and your deployment to dev fails because the index is already there. So it's pretty simple to add this, if not exists, commands to your statements and have your schema changes idempotent. It always helpful, right? And it's also important if you do the rolling deployment, if you don't have downtime, to have your schema changes backward compatible, right? Because what we saw here, the Kubernetes is doing rolling deployment, which means that for some period of time, we have simultaneously running old versions and new versions, right? And they both must be able to work with the database. That's why the schema changes. They should be backward compatible, and then you can use the follow-up migration to clean the things up. This demo application is available on GitHub. It's a public repository. Please take a look, experiment with it. And that's all what I wanted to share today. Thank you for attending this late session and enjoy this great conference.